Alright guys, today's goal, the learner will understand power functions and modeling them. Power functions, what you'll learn about, power functions and variation, monomial functions and their graphs, graphs of power functions, modeling with power functions. Why? Power functions specify the proportional relationships of geometry, chemistry, and physics. Okay? Any function that can be written in the form of f of x equals k times x to the a, where k and a are non-zero constants, is a power function. So if you think about this, y equals 3x squared, that's a power function. It's also a quadratic, but that's a specific type. Okay? The constant a is the power, and the k is the constant of variation, or constant of proportion. We say f of x varies as the a'th power of x, or f of x is proportional to the a'th power of x. Okay? So let's think about this. Alright, so state the power and the constant of variation for the function f of x equals the fourth root of x and graph it. So first of all, I would change this so we see it as an exponent. So remember, this would be to the 1/4 power. So let's do something else real quick. Let's say I had this. F of x equals the cube root of x squared. That would also be this, to the 2/3 power. Okay? So let me 1/4 power. So state the power and the constant of variation. Well, this is a function that has a power of 1/4 and a constant variation of 1. Now to graph it, I know it's not going to be, because 1/4, you can't do odd roots, so I know it's going to be 0. So if I picked 0, 0 to the 1/4 is 0. If I picked 16, so 2, 4, 6, 8, 10, 12, 14, 16. The fourth root of 16, 2, so it'd be looking like that. So let's see if we're right. So the power is 1/4 and the constant variation is 1. And yep, see how it gets closer to 16 and it hit 2? So real quick, tell me what is the power and the constant of variation. So hopefully you said that the power was 2 and a constant variation of -3, or of 3. So, alright. Monomial function. Well, the two things we just did were monomial functions, because all we had was the x to the 1/4 and -3x squared. Those are both monomials, meaning one term. Okay? N has to be a positive integer. Okay. Any function that can be written as f of x equals k, or f of x equals k times x to the n, where k is constant and n is a positive integer. You can't have negative 1/3 or 1/4 power or something like that. So it is a monomial function. Okay? So describe how to obtain the graph of a function f of x equals 3x to the third from the graph of g of x equals x to the n with the same power n. So if you think about this, g of x had to be x to the third. So what does that 3 mean? Well, it's a vertical stretch by a factor of 3, because a is 3. Let's see. We obtain f of x equals 3x to the third by vertically stretching the graph of g of x, x to the third by a factor of 3, both are odd functions. We know something's odd. We learned that in the last chapter because of the function equation, but also it means that it's symmetrical about the origin. So if I flipped that over, if I went x-axis or y-axis, x-axis, or x-axis, y-axis, they meet each other if you reflect it over both, okay? For any power function, f of x equals k times x to the a, one of the following three things happens when x is less than 0. F is undefined for x less than 0. F is an even function or f is an odd function. Okay? So, take a look. So, remember we know how to check to see if it's even or if it's odd. So, if it's not either of those, it's undefined. Graphs of power functions. These are just many examples of different power functions. Tomorrow we're going to be going over regression. So like you're going to get some scatter plots again, and we'll go over the different types of regression. Not just linear, but quadratic, cubic, quartic, logs. There's a lot of different regressions that you can be able to locate. And the correlation coefficient will tell us. The correlation will tell us. The strength of that correlation will tell us what it is. See you guys tomorrow.